lesson 7.3, solving linear systems by adding or subtracting, which is also known as elimination. You should be on page 444. When you solve a linear system, you can sometimes add or subtract the equations to obtain a new equation in one variable. This method is called elimination. Now there's 3 steps to elimination. The first step is to add or subtract the equations to eliminate one variable. The second step is to solve that resulting equation for the variable, and then substitute either original equation, substitute your answer to step 2 in either original equation to find the value of the eliminated variable. So this is probably a lot like the last video on substitution. When you read those, that might not make a lot of sense. It's a lot easier for me to show the 3 steps than it is to write them out for you. But let's pause the video and write those 3 things down first. Okay, you're back. So let's actually use those 3 steps and let's solve some problems using elimination. So we'll do this one first. Now, before you attempt to do the 3 steps, there's one thing we always have to do first. Make sure you line up both equations in standard form. That's probably something else you should put in your notes. Make sure you line up your equations in standard form before you eliminate. Okay, now when you notice, when I line these 2 equations up, do you notice how 2x and negative 2x, if I add these together, they would eliminate each other. They would add up to 0. So that's why you see in the notes here in the book, we want to add these equations to eliminate a variable. So let's do that. When I add 2x plus negative 2x is nothing. They eliminate. 3y plus 5y is 8y, and 11 plus 13 is 24. Now I can solve for y really easy. Divide by 8, and y is 3. Now once y is 3, okay, and by the way, I should go back. Step 1, we added. Step 1, we added. Step 2, we solve for y. So now step 3, take your answer for y, which is 3. Pick whatever equation you think is the easiest. Plug 3 in for y. I think this equation looks easier. Let's plug a 3 in for y and find x. So 2x plus 3 times 3 is 9 equals 11. I can quickly take away 9. 2x equals 2. That means x equals 1. That means my answer is the ordered pair 1 for x, 3 for y. Let's check it in the other equation real quick. So negative 2 times 1 is negative 2, plus 5 times 3 is 15, and negative 2 plus 15 is 13. It checks out. Okay? That's the process called elimination. Let's do another one. So I want to eliminate for these 2 equations. Before I eliminate, make sure you line up both equations in standard form. So the x's, the y's equals a constant. Now, do you notice if I have positive 3y, positive 3y, if I subtract these equations, I will eliminate the 3y's. Let's do it. Let's subtract. 4x minus 5x is negative 1x. 3y minus 3y eliminates. And 2 minus negative 2 is positive 4. Okay, divide each side by negative 1. When you do that, x is negative 4. So I just did steps 1 and 2. I subtracted in step 1 to eliminate the y's. Step 2, I solve for x. Now step 3, take x is negative 4, go to whatever equation you think is the easiest, and plug in negative 4 for x and solve. I think the first equation looks pretty easy. Let's put a negative 4 in for x. So 4 times negative 4 is negative 16, plus the 3y equals 2. I can add 16 to each side, and then I can divide each side by 3, and I found out y is 6. So my ordered pair is negative 4, 6. Let's check it in the second equation just to make sure it works. 5 times negative 4 is negative 20, plus 3 times 6 is 18, And does negative 20 plus 18 equal negative 2? And yes, it does. There's my solution, negative 4, 6. Let's do another one. Okay. To do this problem, okay, again, here's that same note over and over again. We have to make sure that we line up both equations in standard form before we try to eliminate. Do you notice? Let me highlight. Do you notice this equation is not in standard form? So I quickly have to take away 3x from each side and rewrite it as negative 3x plus 4y equals 14. Now the first equation, you notice, I'll circle it here, the first equation is already in standard form. Now let's look carefully. Do you notice negative 4y, positive 4y? If I add these equations together, the negative 4y and positive 4y will eliminate. Negative 4 plus 4 eliminates. So those eliminate. 8x plus negative 3x is 5x, and negative 4 plus 14 is 10. Just divide by 5, and x is 2. So I just did steps 1 and 2. I added in step 1. I solved my equation for x. That's my step 2. Now step 3, we got to find y. Whatever equation looks easiest, plug in 2 for x and find y. I think the second equation is set up easy because I'd have 4y equals 3 times 2, which is 6 plus 14. So 4y equals 20. That means y has to be a 5. So my ordered pair must be 2, 5. And then I can check it in the other equation just to verify that it's right. 8 times 2 is 16. Minus 4 times 5, which is 20, is 16 minus 20 going to give me negative 4? Yes, it does, so this is correct. What I want you to do is pause the video, try questions 1 and 6. Okay, you're back. Your answer for question 1, if you add these equations, the negative 3y and positive 3y eliminate, you ought to work this out to the ordered pair, negative 1, negative 3. The second problem, number 6, first of all, you got to line these up in standard form. So you notice the second equation, I had to rearrange that second equation into that form. Okay? Now, I notice that I can subtract, and if I subtract, the y's will cancel. 5y minus 5y eliminates. Now be careful here. 2x minus negative 4x is positive 6x, and 12 minus 6 is 8. Divide each side by 6. You notice x is 1. And then I can plug a 1 in for x, so I'd have 2 plus 5y equals 12. I can take away 2 from each side. 5y equals 10, and you can see why I'm getting y is 2 then. I can check this in my other equation real quick. If I put a 1 in for x down here, I get 4 plus 6, and if I put a 2 in for y, I get 10. 10 does equal 4 plus 6, so this is checking out. Okay? Word problems. You have not come up with this situation in a word problem yet, so I wanted to cover it in the video. During a kayaking trip, a kayaker travels 12 miles upstream. Now, upstream means you're going against the current. And then they turn around and they travel downstream. Now they're going with the current. Now, even if you've never been in a canoe before, you probably understand that when you're canoeing or rowing against the current, you're going to go slower than you are with the current because the water is working against you versus working for you. Okay? Now, the speed of the current remained constant during the trip. Find the average speed of the kayak. So they drew a little picture here. Okay? From here to here is a 12-mile trip. So maybe I should write that across the top. This is 12 miles. And on the way there, it took me 3 hours because I'm rowing against the current. But on the way back, it only took me 2 hours because now I have the current in my favor. So they want to find out our actual speed. First of all, we need to know that to figure out how fast we are. They want to find out the average speed of the kayak in still water and the speed of the current. Those are the two things we're trying to figure out. So we'll have x and y for those. So let's figure out our apparent speed first. Distance equals rate times time. So on the way there, it was a 12-mile trip, which I'll highlight here, 12-mile trip. The time was 3 hours, so 3R would equal 12. So we must have had an actual speed of 4 miles per hour on the way there. Let me write that in here, 4 miles per hour. Now on the way back, you notice, get a different color marker here. On the way back, the distance was still 12 miles, but now the time was only 2 hours. 2 times what is 12? Well, the rate must have been 6 on the way back, so must have been 6 miles per hour on the way back. So, equation 1, going upstream. My actual speed of the kayak minus the speed of the current, because think about it, the current is working against me, had to equal 4 miles per hour. My second equation, now on the way back with the current, my actual speed of the kayak with the current helping me was 6 miles per hour. Well, there's my system. Okay? This is an easy problem to solve with elimination. Do you notice that my y's, I have negative 1y and positive 1y. If I just quickly add these equations together, these cancel. I get 2x equals 10. X must equal 5. And then if x is 5, 5 minus what is 4? Y must be 1. So this is saying my actual speed of my rowing, okay, my rowing speed must have been 5 miles per hour. So if I was rowing in still water, I would have actually been going 5 miles per hour. Now the speed of the current must have been traveling at 1 mile per hour. And so anyway, those situations could be popping up in the homework and obviously on a quiz or test then. So that's the video. If you have questions, make sure you ask in class.